Okay, welcome back to another video. So today I'm going to explain in details how I managed to install YOLO Darknet with all the requirements, with the CUDA install, with the cuDNN install, OpenCV. So for those you guys that want to jump in YOLO to test in your projects, maybe you can start with this installation and overview of how the YOLO works, how we going to use it, and how to train the machine learning model. So in this video, I'm going to explain to you in details. Since previously, if you have seen my video, I just go through very fast the process because I want to show you the my end project, not the development one. So if you would like to know more, keep watching. So I'm going to a shortcut to install of this and start training your machine learning today. All right. Okay, first I would like to um, start with the top overview of uh, the layout of the YOLO. So first, to make it work, first we need to install YOLO based on its requirement. So the requirement is mentioned in here. You go to alexab.net, and then you scroll down, you go to requirements. This is the requirements. So it mentioned you need to install the CMake, CUDA, OpenCV, cuDNN, GPU with CC, compute compatibility, and GCC or CLang. Okay, and it also provide the version number minimum, so that it compatible between each other. So the first step is installation of your requirement. What I did is I have create a snippet. I'm not sure how to pronounce that, but it's a one script to install everything. So I'm going to copy this, or I'm going to clone this. All right, open my terminal. I go to my desktop. Okay, so I'm going I'm cloning I'm clone here. Go to install, and here is and here is the script. And to see what inside in details, you can go to you open it. Okay, in here I describe some of the why I motivated to create this kind of tutorial for you to install, because as a beginner I also once hustling with the installation, especially with the GPU, CUDA and cuDNN. I just install it with uh, based on the instruction, but I'm not sure or not knowing is that my installation is a correct path or not. So luckily I found a streamlined installation step. So I wish you can use this script to run installation process and save your time, save your resource to do some other machine learning work. So at first we're going to install a Git, then install a CMake. I install a CUDA 10.2 here, CUDA 6.7.64, and then confirm that I have installed Python 3 and PIP3, and then I install the OpenCV, and then just check the GCC version. Okay, so a bit of clarification. If you see here, before we enter the installation process, okay, CUDA that mentioned here is a 10.0, and it needs cuDNN more than 7.0 for CUDA 10.0. But you see here, I'm installed for 10.2. And I installed the cuDNN 7.6.4 that compatible with the CUDA 10.1. So did it work? The short answer, yes. The long answer, I'm not sure. Uh, but I made some comparison between using GPU or CUD and cuDNN and without GPU and cuDNN for darknet. So I can see some comparison in time consumed for the training, for the detection, So I believe everything worked, and I also tested the cuDNN installation, and the test is passed, and the CUDA driver seem installed. So I'm going to show you just to validate that what we're doing here is legit. Okay, first I think first change the we make the script to be executable. So I'm using sudo chmod plus executable here, and easy install. You can see after you change the file into executable, the color is different. So when you see this color in, for example, Ubuntu, you know the script file can be executed. Okay. Then when I run this script, it's going to install all of this. But beforehand, for the I have some updates. Okay. Uh, okay. Wait a moment. Open folder. Open folder. I made some update on this, even though I already put on the snippet to add a bit bucket, but actually I have a few update for this. Okay, tools, and this is yes, this is the updated one. So I'm just copy here and paste here. Don't worry, later I will change this update inside the Bitbucket, so when you watch this video, the code is already updated. Okay, so after it install the CUDA and then set the CUDA path, after that we'll install the cuDNN. But before that, you need to download it manually. So I try using widget to download this file. However, to download this runtime library for Ubuntu, cuDNN runtime library for Ubuntu, but it is in secure location, means even in the website you need to log in inside the NVIDIA website, then you can download it. Unlike the CUDA, you not necessarily to log in to download the driver, but for the cuDNN, you need to log in. That's why it's so I don't want to hassle with all the password things, etc. So short way is you just download it at this link before you run the script. Okay, before you run the script, actually you see I already logged in. So if you not log in, you will be prompted with a login username and password. Just create your account, it's free. So you need to download this cuDNN runtime library for Ubuntu 18.04 Debian file, that file. So I will install with 7.6.4 for CUDA 10.1. So I'm going to install this. Sorry, I'm going to download this, not yet install. Download this and then this too. Okay, it may take some time to download. You see the file is quite big, 175 4 megabyte. My internet speed is not that good, only 2.9, but we get there. No problem. No problem. Okay, let's see where it's downloaded. All right, we done. So from here, I just cut this, go to the desktop, I paste it here so that when I run this script to install the cuDNN library, it able to find this file. Okay, this file should be the same. Okay, this file should be the same name as what you install. So for example here, deb here, AMD64 deb. Okay, make sure this name is aligned with here. Oh, I noticed something. This not supposed to be here. Okay, then when you already put all of these three cuDNN library inside this easy install YOLO requirements folder. So you're good to go. Okay, let's run. Let's run it. Whoops, before that. Because of I create this script without using sudo. Okay, some of the installation we need a sudo to run it. So, but I don't want to make it officially inside this script because maybe it will change something that you're not aware of. So I want to make sure that you know what you're doing. So, but to run this, you just append sudo in front of this script, then the whole script is getting the same permission as a sudo. So let it run and wait for it. Minutes, 19 seconds. Okay. Meanwhile, while it download, let's see if I can have this time to explain to you a bit about all of this. So you know that we currently doing this installation of YOLO. Next is we're going to prepare the dataset. What is dataset that means here? Okay, forgot to tell you earlier what is YOLO. Let me show you what is YOLO. A bit typo here. What we going to expect of having this YOLO. I'm just going to play the video here so you can see. Okay, so you can see that it able to detect multiple objects, many objects in real time frame. This is not a speed up frame. You can see it can detect person multiple in one in this single frame. Already have like at least in my bare count minimum is like a 20 or 30 objects. And all of this is real time and it's very fast. Even though it's maybe the precision is not that good, but if you have a decent GPU training, you can have this performance with this speed. Yep, pretty much explained in this video. So we're going to perform this detection, object recognition. We're going to able to detect this dog, this is keys, this is person. We're going to train. By default, this machine learning is not a machine learning if it not learn, right? So we need to prepare them. We need to give them some data, whatever data, image, or we're going to give them information or metadata for certain things so that it can learn and see the patterns, and then the next time it sees something that's similar, it classify it as the thing that we teach them. For example, if I teach this kind of object is a person, so the next time it sees similar thing, something like this, it consider it's person, even though it's maybe it can be a dog or something, but garbage in, garbage out. If we teach the machine learning the garbage data set, then it will produce the garbage as well. So let's see, another 6 seconds. Oh, already download the CUDA Ubuntu. Now this installing, I believe. Let it be. Okay. And here is this some comparison between YOLO Darknet and what is so popular. I'm not sure what is popular. Maybe popular like Michael Jackson popular or popular like our local artist popular. I'm not sure. For me, it's quite popular. So YOLO Darknet you can compare with the another method, existing method like a SSD, um, RetinaNet, and some other like yeah, RetinaNet and SSD. I haven't tried this SSD and RetinaNet. I'm not sure, but at first I start knowing this object recognition is with YOLO. So I'm only have tried with YOLO V3 Tiny and some with YOLO V3 320. Okay, so you can see here, this is the result of this is the result based on this train and test dataset based on the Cocotran. This is kind of benchmark dataset so that we can compare apple to apple between model for their mean average precision map, the frame per second, the speed of the detection. Okay, let's see, do we have any issue? So far looks okay. PIP is being invoked by an old script wrapper. This will fail in future version of PIP. Please see, but it's not. It's just a warning. No problem. So looks everything okay. Is everything working? Okay. So before we ensure everything is working, what we need to do is we need to double check the version lah. Okay. So we're going to check the CMake version. Okay, 3.10. You see in Alexi AB, dimension must be more than 3.12, but for us, at least for me, it's okay since I'm not using CMake to build darknet. I'm using make later on. So I don't care much about this. I just put it here. So if you need exactly to use, if you need to build it using CMake somehow, then you need to make sure it's more than 3.12. And then NVIDIA CUDA, okay, to ensure this is installed correctly, actually what you need to do is after you install of this, after this script is run successfully, you need to restart your machine. So to identify if the CUDA is installed correctly, one is command is nbcc. So you can see CUDA compiler driver here is installed correctly with the release version 10.2. Excuse me. So and then the next one is you can run NVIDIA SMI. If you able to see this, then means the driver is installed correctly. The CUDA version is 10.2. You can see my memory size for my graphic card is 2 GB, what is currently using. My GPU is a GTX 1050, 75 watt, currently at 45%. And then, yeah, this is the process. So this is basic. So two things for you to know if your CUDA installation is correct and work, run this command. And then for the cuDNN, how are we going to ensure it is work? Okay, so you need to go here. For the cuDNN, you're going to here. Yeah, same again. Okay, sample. I'm not remember. Run samples cuDNN for to test it. Installation guide. You need to installing Windows, cross compiling Linux, and then you going to verify. Okay, to verify you need to do this. Copy the cuDNN sample into home or whatever path that you like. For me, I going to put it at home. So I'm at home, right? cuDNN sample. Okay. And then go to go to here, just copy and paste, easy lah. Okay, and then make clean. Okay, and then make. This is not related to our machine learning training program. It's just only to verify the cuDNN install on Linux is working. So run here. Testing single precision. Okay, what happened? There are one CUDA capable driver capable device on your machine. Device 0 SM clock. Using device testing single position student failure, internal error. Okay, that's new. Happen cuDNN error student. Let's try again. Oh, okay, now it's passed. Okay, as expected, test pass. Okay, and then we sure that this cuDNN installed properly. After that, we need to ensure that if our OpenCV is correctly installed. So one thing to know is you're going to enter the Python terminal. Okay, then you're going to import the CV2, and then you're going to print CV2 version like this. Then you get a 4.2.0. Okay, previously I got a 3.2.0, but now it's a 4.2.0. I'm not sure if my next, but I believe it should be okay. And then exit, and then check the GCC version. GCC version is 7.5.0. Okay, does not have any requirement to be what version, but as long as installed. So yeah, this script is updated. What I'm going to do is I'm going to delete here just to prevent a confusion. Okay, to log in, snippets or snippets, I'm not sure. Tell me in the comment below. Where's my snippet? Snippets, snippets. This one. Oh, okay. I click workspace. No wonder. Edit. Okay, already updated. Snippet. Okay, let's try. Just to ensure. Yes, this is the same one. Okay. Okay. Nice. Okay, now we finish this one. Okay, we finish the installation of YOLO. Okay, for the dataset preparation. First, okay, now this one I'm not need anymore. Okay, this one too. Oh, no need to install. Okay, let's copy. Okay, clean up some a bit here. Okay, now we're going to dataset preparation. Um, Dataset preparation, I create this kind of folder structure. This is nothing. No one mentioned this, and I just make it up because it worked for me, and it worked well so far. Okay, so inside the darknet, oh, beforehand, you need to download or clone this Alexei AB repo for this dataset preparation. For me, I just like to, okay, I just clone it. I also don't want to cuDNN in here. Music snap. Okay. Now I'm going to clone the Alexei AB repository here. I'm going to show you the structure in details. Okay, going to desktop, home, darknet, open, close without saving. Are we done? Yes. You can see here, what I'm proposing is inside the darknet root directory, there should be some backup folder and other folder. This training folder is made up for this training purpose. So you can see inside the darknet repository, let's make it something like this. .NET repository. So you got a build, CMake, data, include folder, everything. So what I'm suggesting is you create to start the training. You make a training folder. You make training folder, and then inside you create another folder called dataset. Okay, and then another folder to keep all your model configuration. Either YOLO v3 or YOLO v4, your class names. So you put it in here. For example, I'm suggesting here, if let's say you have example model, a single class model, or cat model or cat class. So let's say model cat class, for example. Okay. Okay. Inside this dataset, it's supposed to save images, bunch of images, training images that you're going to train. For example, if I'm going to train a model to detect a cat, to differentiate between a cat and dog. So I'm going to have a bunch of images of cats and dogs inside this dataset folder. And this txt files is YOLO labels. So every image that you put inside the dataset folder, you must have a .txt or YOLO labels file, even though the object is not inside the image. Okay, let me show you. For example, let's say we find cat image. This cat, I just save the image. Put the image in home.net training dataset, and I save cat1, I call it. So inside this training dataset, we got cat1.jpg. So we should have one file called exactly the same name but txt, where it is in the same folder inside the dataset, and inside this .txt file is the label or the position or the location of the face of the cat, or the area that you want to detect. I show you for much easy lah. Okay. Uh, to make this label, we are not going to make this like a manually typing here. No, we're going to use a software called a label image from Zutalin. I'm not sure if I spell it right, pronounce it right, sorry. So from here we can create a bounding box and then create the label. After that, it will create us the txt file. I'm not sure if got the example here. If not, it's okay. You just need to download, build, or much easy way, like I always do, is using pip to install. Where's the pip to install? Oh, pip to install, pip, no. This, get from py, but only Python 3 or above. Luckily, we have Python 3.6, so we can use this. Okay, and I also have a install already. So what I need to do is only call this label image, and then just run it. Open the directory path where the image is located. For example, this one is training dataset and inside here. So we open, and then we change save directory where we're going to save the label. the .txt label. Okay, so we open. Okay, so inside here, show cat1.jpg. If you have multiple image, it will show everything here, and you can iterate the next image to label. To label it, you create the n rectangle box. Okay, but before that, for this YOLO, you need to ensure this tab or section here is showing YOLO, not Pascal Vogue. So you need to click to toggle it. So make sure it's YOLO, and then you can label the cat. Just click and drag, and then just label it cat. Whatever name that you like. It doesn't have any schema. It depends on you. And then when you save it, see the cat1.txt have this bunch of numbers. It actually the coordinate of this image, of this bounding box, the starting point, the end point, the width, um, and the first one is the class. The first one is class number. So for example, you see automatically the classes.txt is created. Okay. So for example, if I create another one, I put it is like the I. Okay, so we have cat and I, and I create another one for the I. Okay, I. Okay, so when I save that, classes.txt already updated with the new label that you put, and then it has three. From here we can see it this image has three labels. So and two class. So this is the first class 0. Class 0 means the cat, and class 1 and 1 is the I. So yep, we have a 2I here and the whole. You can detect inside the bounding box, and you can create another bounding box inside the bounding box. Okay. Yep, that's what I'm going to explain in dataset here. This is what we're going to prepare. Looks simple. So the next, if you let's say you have another image, then you're going to create like this again and again. As Alexei AB mentioned, each single image that you want to track, you should have like 2,000 image minimum. But as I mentioned, I just do it less just to try it out. Okay, so this settle for dataset. The next one is this inside this model. Okay, inside this model class here, what we need to have is .data file, .names file, configuration file, train.tsc file, and test.tsc file. Okay, I show you how it's done. You're going to configuration here. Okay, now we're going to copy all of this. We unnecessarily to create a new one for us. We just copy from others. Okay, we're going to copy this Coco dataset, copy it, create new file, save it under training model cat class, and I say that model, for example, model cat dot data. I just change the name, and then from here we know that we only detect one class, right? Okay, if before that, and then we're going to copy the .names file. Just find whatever here, coco.names for example. So you see coco.names is only just like, do you see the pattern? Dataset here, the class.tsc is similar, right? So it's basically it's the same, but uh, it in this .data is finding .names file. So we just feed in the .name file. So what do you need to do is copy this, create new file, and save it under training model cat class as model cat.names. Okay, now we have model cat data, model cat names, okay, under here. The next, we should have a configuration. This is the network configuration, neural network configuration. So we no need to create one. Alexi AB inside this repository have bunch of configuration that you can copy and test. For this example, I'm going to use YOLO v3 tiny. And then I don't want to edit something like this, change the everything here, because this kind of should be like a reference for us. So I'm going to do same, create new file, save it under darknet training model cat class. Then, but to make it for me to remember what is this configuration reference from, so I just put a YOLO v3 tiny dot cfg. Maybe you can put a model cat dot cfg perhaps. Okay, all right, looks good. Now we have configuration. Okay, the next we need a train.txt and test.txt. You just create this file empty first. Later we'll explain what it does and what it should be here. Test.txt. Create a new empty file. Train.txt and test.txt. Okay, now we have all of it. 1, 2, 3, 4, and 5 files. Inside this modelcat.data, it contains all the paths to this file. Names file, configuration file. Sorry, I mistake. 1, 2, 3, and 4. 4 files. Train.txt file, the path. Okay, so we need to update. Okay, the class that we're going to detect is 1. Remember, we're going to detect a cat image. Sorry, we're going to detect two class. One is the cat and one is the eye of the cat. Okay, for example. Okay, so we're going to have two class, and then this train is asking the path for the train.txt file. Okay, for here my path is at this. I can, so going to desktop. Nope, going to darknet. Okay, I'm going to training model cat class. Okay, I'm get the path here. Just copy, and then paste. And here train.txt. Similarly, for the valid, you need to feed in the test.txt path. Even though it's empty for now, it's okay. Later we'll put something here. Okay, and then valid here, not necessarily. The names, the path of the names, same. Sorry. Paste the names path. The name of the path is model cat dot names, and the backup folder. This backup folder is for when we training, we will have many iteration, 1000 iteration, 2000 iteration, 3000 iteration. So for each iteration, for each after it reach some milestone or 1000, for example 1000 iteration, it will save the train model. Even though the train model may be not so precise, but it just safe for you to test it, to check it the precision. Maybe you can stop the training when it meet your benchmark or requirement. So it will save to this path. So for us, we're going to use this home darknet backup. Home and basically darknet and backup folder. The backup folder, if you can see, it's not here, but it will automatically created. This one you can delete, and yes. Okay, now we have 1, 2, 3, 4, and 5. Just make sure we have a 5 file inside this folder. Yes, we have 5 files. So this model cat eyes. Okay, now in this configuration we need to update it. First we need to find this YOLO section. Inside here, the class, we need to update it. So I'm just find whatever class level class equal to 80 here. So I just find all. I edit to be 2. And then for the filter here is it got a simple calculation. For example, if we have a one class, the formula is something like this: n of class plus dengan 5 and times with 3. 3 is the YOLO Darknet filter, um, as what Alex AB mentioned inside the repo. So let's say if we have a 2 class here, 2 plus 7 and times 3 going to 27. Sorry, 2 times 5. If we have 2 plus 5 times 3 here, we will have 21. So what I'm going to do, I find this filter equal to 255. I'm just change to 21. And just reminder, you cannot do something like this here. For example, you have a one class something. It's not possible as Alexei AB mentioned in one of the wiki. Okay, so we done. That's it. Oh, one more thing. For the training purpose, we're going to use this batch number. Batch 64 and the subdivision is 2. And we're going to comment out this. So the batch and subdivision here, if if you're facing your GPU memory is not enough, CUDA out of memory, so you just need to increase these two into 8, 16, 32, or 64. So batch and division here, you can read more details on wiki, what it is about. So training, yeah, meaning configuration, parameter in configuration file. Okay, you just open here. You can see batch equal to 1, number of sample image letter. So let's say if the batch is equal to 64, means in one batch, 64 images will be processed. Subdivision equal to 1 is the number of mini batches in one batch. So even though we have a 64, uh, the ideal one is, for example, the best one is maybe we have a 64 image that we process once and subdivision is 1. So we process only once the all 64 image so that it become faster. It become faster in the training. But in one moment, you need to digest all these 64 image, and it may require your GPU to be much higher in memory size or RAM. So in that case, if you don't have enough memory uh, size for your GPU, so you need to increase the subdivision. For example, in one time we're going to process the 64 image, but if we don't have enough memory, so we divide that operation by 2, 8, 16, 32, or 64, so that it it will reduce the usage of the memory to process that image in one time. Simple as that. And then this is the width and the height of the image that you're going to be processed. For example, even though your image is a big 1920 times 768, but when you set this width and height to be 416 pixel in this configuration, so the image going to be shrink. You can see here. So every image will be resized to the network size during training and detection. Okay. Okay, so just need to put something like this. But I know my system, it should done, I think around 16 or 32. It's not that power. I'm having only 2 GB of RAM here. So I'm just put it 32, okay? Or 16, just to show you maybe I going to get out of memory. And then the train.txt and test.txt here. What should we put inside? Okay, remember that we talked about the machine learning. We're going to train the model to teach about to teach the model. This is the cat face and this is the cat eye. So we're going to put the list of images for training process and list of images for validation processes, which mean when we should have a two subset of data. So one is for training. For example, we have 10 images for training. After we training these images, 10 image, we're going to test the same model with the test list of test images that we provide here, just to ensure that it's not have a kind of bias, because let's say it's kind of like a answer to the question that we're going to ask in real world. So after we've seen enough cat images, so we're going to identify if this model is robust enough to identify the new cat images that it will see. So this test.tsc going to have isolated dataset for us to test and also for this model to be used. So in this case, our cat image only have one. For this example, just to make it run, I'm going to download more. I'm just going to save the image, like the training dataset. And just for reminder as well, you need to use .jpeg, .jpg file. I have no luck with the .png file or .jpeg file, but so I just use only .jpg file to be consistent. And since it's worked, I just stick here. And then download again, save image. Okay, cat 5. Okay, now we have cat 5, and I'm going to run label image again because I have a new image. Right? Open the directory, open this, and then change the save directory to here as well. Okay, when we click next, we have a new image. You can create a rectangle box, or you can, the shortcut is the W, key W. So I just press key W and label as cat. Okay, you also can tick here, use default label. For example, if cat, then whatever the next is automatically is cat. So because you're going to handle a large of data set to label, okay? So it will be troublesome if every time, if we're not going to use this, then every time we need to put or click something. Okay, so the next, for me, I like to solve everything like first, the first class first. The first class, detect everything, and all of this is cat. Okay, all image done. So I believe if the file is change 0 0 1, why it's not detecting? Never mind. Model cat names, cat and I. Yep. Okay. Next, I'm going to label the I. So I just change here I, then I put a label and then put a label. So it become faster this way. Example. Next. Then here same as well. Okay, done. When you go here, just close here, close, close. So now we have 5 images with 5 labels. Okay. Okay, for this train.txt, the rule of thumb is it should take 80 to 90% of the training images for the training process, and the balance is for the test process. For example, now we have 5 images times with, for example, 0.8, 80%, then equal to 4 images. So 4 images, cat1, cat2, cat3, and cat4 going to be trained, and 1 going to be inside the test.txt. What we need to put here is the absolute path for the image. ls everything.jpg into model class train.txt. Okay, it so you can have all this, but you don't have the prefix. Copy model darknet training and cat. We forgot one dataset. Training dataset cat1, cat2, cat3. Okay, and we take one to use to be placed inside this text.txt. So train.txt and test.txt is to keep the path of the image that you're going to train and test. Okay, all is done. Okay, we already put the path to the train.txt and test.txt, model cat.names, and model cat.name already have a cat and I here, and we already put the links to the image. We already have the label for the image, and we already config the YOLO neural network configuration for the training. I believe we good to go. Okay, that is what it mentioned in dataset preparation. So now the dataset is prepared. Okay, we label it, we create a configuration around it, so it ready to be training. Okay, for training process, first one, you need to compile the darknet. Until now, we haven't compiled it yet. We only install the YOLO requirements. Okay, we only prepare the dataset, but for training, you need to compile it first. How to compile it? Okay, when you install everything is correct in the first place, to compile it will be easy. First, okay, let me show you. First, before we compile, we need to update the makefile to suit our process. So we're going to change this file. Sorry, we're going to change this config to 1. 1 is enabled, 0 is disabled. So mention here is we're going to use OpenCV. We're going to enable AVX and OpenMP. So AVX and OpenMP is to speed up on CPU. If error occurs, then set AVX to 0. If your PC doesn't have any GPU, you're still able to train the model and perhaps able to get a decent speed of this YOLO darknet detection, but you need to enable this AVX and OpenMP. Of course, it cannot beat the GPU speed since GPU have more cores than CPU have. Okay, at first I'm going to enable this and disable the GPU and cuDNN just to make sure, just to show you the difference between using GPU and not using GPU for machine learning process. Now, let's make it. It will take some time. In the meantime, to start the training, we need to download the pre-trained model. Okay, this pre-trained model is like a half-baked model that we need to use to train our model. Okay, already compiled. So first, let's download this file. Download. Since we use YOLO v3 Tiny, so we download the YOLO v3 Tiny convolutional.11. We download it. I cut and put in darknet. Okay, inside here, for me, I would like to create a new folder called weights to keep all the weights for the pre-trained model. So I don't want to put it randomly, so it will be easier for me to find it later. Okay, I put it here. Okay, since our build process is successful without errors, even though it's not state successful here, one thing that you can see, if after you compile, you should have a darknet executable file here. So darknet file. So if you put something like this and then you tap and it appears, then means the compilation is working. Then to start training, you need to use this command darknet detector train, pass your data file that we created earlier, pass to your .cfg file configuration file, and also pass to your pre-trained weight. And then the last uh, option is to view the map mean average precision while the training is running. So I'm going to do exactly the same here. My data file is at training model class, and then since I only have one, and my configuration is at, and then my pre-trained weight file is at, oh, so, YOLO v2 tiny convolutional.11. And then if I put map here, when it runs, it a bit slow. You can see that. It should be fast, you know. If using GPU, it's not that this slow. If this slow, because this not even one iteration. You need at least like a 1000 or 2000 iteration. You can imagine how long you need to wait to reach 1000. And as Alexi AB mentioned, if you have two class to detect, you should train your model at least 4000 iteration, or minimum is 6000 iteration to get viable results. So a bit slow. I just cancel it. Mm, monitor process darknet and the process and process. Okay, thank you. Okay, you see that we're not able to. It's quite difficult and it make our system like a hang something. Okay, now we change this to 1 and then make clean, make again. This the result, the speed of the process, the speed of this training process maybe varies since um, I have recording. I have using maybe the GPU for recording purpose. I got a webcam here. I got a screen recording here. Maybe it affect if so. Usually when I training this, I close down all the application that not necessarily that I use. For example, like browsers, all the folders. I close everything so that GPU is able to focus more on the training. So the training process will maybe can be faster because it can utilize all the memory. Take a while. Okay, done. So what I'm going to do, I just rerun again the same command, but this time using GPU. Okay, you can see this is what we expecting. If using GPU, it become faster, but still the left hours is very much high, 3 hours, 300 hours. Iteration is number 6, and this is the loss that currently have, which really large. But don't worry, usually for the image that, for me, like I having like 500 image, it's only take like sometimes it take 6 to 8 hours, depend on the configuration of your neural network setting. You can see fast, fluent, nothing block my system. Okay, so that's all for the training purpose. Okay, now since we only have 5 images and it will take a while, even though I download all the mini image for the cat just to show you the training, I don't think it's worth it. Maybe you need to try by yourself so you can understand the process much better. Instead, I'm going to show you the how after we train the model, what we should have, and how we're going to use this train model in our detection. Okay, for that uh, for that exercise, I'm going to download a full model, a full train model for YOLO V3 Tiny. YOLO, sorry, this is wiki. YOLO V3 Tiny. I want to download the full image of the PRN weights. Or maybe not. I can download this YOLO V4 weights. I download this YOLO V4 weight just to show you after we download, after we train, we should have something like .weights file, not like this one. This is when you see this .conv convolutional.11 is kind of partially trained. It's a pre-trained model going to be used in our training. But after we train the model completely, we're going to have something like YOLO v4.weights here. Okay, now it's still downloading. Take a while. And to prepare that, we're going to use darknet detector test to detect a single image. So, okay, finish download. I cut this one. I put in darknet and put in weights. So the command is darknet detector. For detecting a single image, just for example, you're going to use test and then the pass to the, okay, since this is not the model that we trained previously, like using training model class pass, so this is for YOLO v4. So we need to find YOLO v4 configuration file and data file. So for the data file, we're going to use this coco.data. The example you can find in here. If you search detector test something, you can see exactly this is the command that exactly that I'm going to run. Just paste it, just to make sure the path is correct lah. Weights, I put the YOLO v4 weights in weight folder, and then the configuration in YOLO v4. Okay, just to ensure inside this configuration folder should have a YOLO v4 config. Okay, nice, we have. And then inside this configuration, we should use the coco.data. This is the train model. People have trained this YOLO v4 model using coco dataset that able to detect 80 images in a single frame. So we're going to use it for the test. Okay. And then it asks us to enter the image path. Okay, you can find inside data, for example, giraffe. So I just copy the path, I paste here. Then you can see it label it correctly and perfectly. Next, let's say if we detect this horse, it can detect horse 1, okay, 2, and 3, and 4, and 5. Okay, this is, even though it's overlap, you can see that the horse is overlap between each other in single image. But if we label it properly, we train it properly, it's able to detect as accurate as this. Okay, and another example, if let's say this person, you can see dog, person, and horse. Okay, and you can see, for example, for this giraffe image, I just want to put some benchmark. I'm going to copy here. I'm going to paste it. This is with GPU, YOLO v4. I'm going to just demo with you without GPU how long it should take to run YOLO v4. So in this make file, I'm going to make it 0 back. Okay, and then I'm going to make clean. I'm going to make it again. Okay, now if I run the same thing, the same way, the same configuration, but without using GPU, only for detection, I'm use this giraffe image and it detects in. Okay, I just close it and copy this for the comparison. And without GPU, it takes 3.8 seconds, almost 4. However, in using GPU with all the CUDA, cuDNN installed, we only detect in 124 millisecond, fraction of seconds. So you can see the difference um, it make. Even though you have not a decent GPU like me, I only have like GTX 1050 with a 2 gigabyte memory. The speed is usable. I say if let's say you're going to use this YOLO Darknet in a real-time application. Okay, so we finish the setting up YOLO environment for your PC. So if you have anything to ask, just put inside the comment. If the question is more difficult or trivial, you can send email to me. I will put my email in the description below, so you can ask or you can connect with me LinkedIn. And if you like this video, you like to see some more of like this tutorial, subscribe and hit the like button. So see you next time. Have a nice day. Bye.